And by the time NASA was created and the Atlas missile was actually being test launched and Project Mercury was going ahead, Harvey Allen's blunt body shape had become a matter of public knowledge. It was no longer classified. And there was an engineer who was in charge of the design of the spacecraft for Mercury named Max Faget. He was at NASA's Langley Research Center in Virginia. And Faget was, like Harvey Allen, an out-of-the-box thinker, a very brilliant engineer. And he realized he had met Allen at some conferences when he went out to Ames. He had heard about the blunt body theory and realized that that was the way to go for the Mercury spacecraft, that that was the only way to build something that could be carried by the Atlas and be able to re-enter the atmosphere safely. And he convinced his colleagues that that was the way to go, and that became the central concept for the design of the Mercury capsule. Now here is an early drawing of the Mercury capsule that uses Faget's design, and it was created by Faget's collaborator, another very talented engineer named Cadwell Johnson, who was also a superb artist at rendering engineering ideas and making them visible. And you can see the basic concept here, that blunt heat shield, one astronaut inside a relatively small cabin, and that's the basic shape that Cadwell Johnson came up with. Here is what the final Mercury design looks like. It has that blunt heat shield, which you see on the right, and I love these. By the way, I love these retro future graphics. This is a NASA graphic that was done for public information purposes and for anybody inside NASA who was giving a talk about Mercury. You know, they'd use this kind of artwork. There's a lot of this stuff on the internet. If you want to go have a look at it, just kind of Google around and you'll find this stuff. But you can see the way the spacecraft is laid out, the instrument panel, the overhead window that's overhead there on the cabin wall, the side hatch. You can see the parachute is inside a protective compartment, and there are other instruments. There's also a periscope that can be extended for the astronaut to be able to look around while in space or in flight, and then the view through the periscope would show up in a kind of a round window on the middle of the instrument panel. Now, one of the most important things that Faget came up with in designing Mercury was the idea for a contour couch that would help the astronaut withstand the tremendous acceleration and deceleration forces, the G-forces, of launch and reentry. And during a launch, and especially during reentry, those forces could build up to many, many times the normal force of gravity. Tremendous stress on the body, and so you needed something that would give the astronaut a fighting chance of withstanding that stress and also staying conscious, because there was a danger of blacking out from the blood being drained out of the head. So Faget had the idea that you'd have this couch. It would be created for each astronaut individually. It would fit the shape of his individual body. And you can see on the right, John Glenn is lying in the Mercury simulator and in the attitude that he would be in for launch as well as reentry. Now, the interesting thing is that during launch, the acceleration is coming from the rocket engines and pushing him up. And during reentry, it is a deceleration from the atmosphere slowing him down. But in both cases, the force is the same. It is going sort of downward by his reference frame. In other words, they use the designation of eyeballs in. In other words, the force tends to push the eyeballs back into the head. That is the direction of force in both the launch acceleration and the reentry deceleration. And experiments had shown that that was the direction of force that would be the best able to tolerate, so that you did not have as much blood draining out of the head leading to unconsciousness or any other ill effects. So that was the setup for the survival couch, the G couch, which was another of Max Faget's innovations for Mercury. Now here is what the Mercury spacecraft looked like when you look at it from the outside. This is actually an unused Mercury capsule that is on display in San Diego in California. And you can see again that broad curved heat shield, which is coated with a heat-resistant material, or actually a resin, that is actually made to char and burn away and carry the heat away with it. It's called an ablative heat shield, and that was the way in which you managed to dissipate that residual heat that makes it through the shock wave during reentry. So you put a thick coating of that ablative material, that resin, on the heat shield, and that creates a way of withstanding the heat that you do experience as you come through the atmosphere. The rest of the spacecraft is covered in a kind of corrugated metal called Inconel, which was a high-temperature alloy developed for very high-speed aircraft like the X-15 rocket plane, and was now applied to Mercury to insulate the rest of the spacecraft, which would not get nearly as hot as the heat shield, but would nevertheless experience some significant heat during reentry. Notice that the shape of the capsule is a kind of like a styrofoam coffee cup. That was intentional, and the cylindrical portion at the very nose of the spacecraft, that was in order to make the capsule able to assume the correct orientation, even if its maneuvering thrusters were to cease functioning. It did have a set of small turning rockets, which were used hydrogen peroxide as fuel, and that was normally the way that the astronaut would control the orientation of the spacecraft during reentry. But Faget wanted to have a backup in case those thrusters malfunctioned. And so he actually designed the spacecraft so that whatever attitude it had as it hit the atmosphere, it would straighten itself out and assume the proper orientation of the heat shield pointing directly into the line of flight. Now, two other things I want to point out. At the left, you see a kind of black and white striped cylinder with three kind of bumps on it. That is a package of 3 solid fuel retro rockets that would be used to slow the spacecraft and let it fall out of orbit and re-enter the atmosphere. So again, solid fuel rockets, because they would be reliable. They didn't require mixing of any fuel. You just ignite them and they burn for the prescribed amount of time. They're attached to the spacecraft with 3 metal straps and held onto the heat shield. Then once they're fired, those straps are released and the retro package is jettisoned and allowed to burn up in the atmosphere. Now on the upper right, notice the reddish-orange tower with the cylindrical feature beyond that, and 3 rocket nozzles. That is the escape rocket, again solid fueled, which would be used in case of an emergency during launch. And if the rocket were suddenly veering off course, or if it was about to blow up, or if there was a fire in the rocket, there would be an emergency detection system in the spacecraft. It could be activated automatically, it could be activated by the astronaut, or it could be activated by mission control to fire those solid rockets and pull the Mercury spacecraft away from the booster, at which point, and once it was on a safe flight path, the tower would be jettisoned and the spacecraft would come back down, deploy its parachutes, and splash down in the ocean. and save the astronaut that way.